Hi there. Welcome to these practice questions on being able to use substitution to integrate a function. Now what I'd like you to do now is actually to pause the video and then have a go at these two questions here. Integrate both these, question 1 and question 2, and then when you're happy with your answers, then restart the video and we'll go through these together. So if you pause the video now and have a go at question 1 and question 2. Okay, welcome back. Hopefully you've had an attempt at those. Now let's go through these together and you check your answers with me. So on this first one here, I'm going to use the substitution method. I'm going to make this part here within the brackets, I'm going to make that equal to u. So I'm going to write u equals x squared plus 3. I now need to differentiate this expression here. So du dx is just going to equal 2x. Now what I'm going to do is I'm going to make dx the subject, so take the dx up to here and then divide by the 2x, so I end up with dx equals 1 over 2x du. Now I'm going to replace my x squared plus 3 with u and my dx with 1 over 2x du. So still within the integral, I've got 2x, and then this becomes u squared, and then my dx, I'm going to times this by 1 over 2x with respect to u. So if we can see, let's look to see if we can simplify anything. We can, because this 2x here multiplied by the 1 over 2x is going to cancel out. So I'm going to end up just integrating u squared du. If I integrate this function, I raise the power by 1 and divide by that power, so I get u to the 3 over 3. I'm going to write that as 1/3 u cubed. All I now need to do is replace the u with what I made the substitution in the first place, so I end up with 1/3, put this in brackets, x squared plus the 3 cubed plus the constant of integration c. Okay, question 2 looks a bit trickier. It is a little bit more complicated, but we're going to use the same method. The first thing I'm going to do though is I'm going to change my cos squared 3x. So I'm going to write this as cos 3x all squared with respect to x. This makes it easier to make my substitution. So I'm going to have my substitution here as u equal to cos 3x. If I now differentiate this part to get du dx, cos 3x differentiated gives me minus 3 sin 3x. That's just using the chain rule. And now I'm going to rearrange to make dx the subject. So dx is going to equal 1 over negative 3 sin 3x du. It's now time to replace my dx and my cos 3x with u and 1 over minus 3 sin 3x. So if I do that, keeping it within the integral, I end up with sin 3x. Cos 3x now I'm replacing with u, so that's u squared, and my dx was 1 over minus 3 sin 3x. Now we can see here that the sin 3x multiplied by the 1 over sin 3x, that's going to cancel out just to leave me with 1. So I'm just left here with 1 minus 1/3. So I end up with minus 1/3 u squared with respect to u. Any constant it's best to take out of the integral. So if I take the minus 1/3 out, I'm just integrating u squared with respect to u. So I end up with minus 1/3 u squared integrated. We've just saw on the previous one, that becomes 1/3 u cubed. And now all I need to do is replace my u with the cos 3x from my initial substitution. So I end up with minus 1/3. Now I've got 1/3. U, remember, was cos 3x cubed. And this minus 1/3 times the third obviously gives us minus 1/9. I'm going to now replace my cos 3x with my cos cubed 3x, and then constant of integration, add c.